What happens when the sun dies? For as long as humans have existed, the sun has felt permanent. It rises, it sets, it warms the ground, lights the sky, grows forests, powers weather, and gives life to everything we know. Ancient civilizations built myths around it. Some worshipped it, some feared it. Some believed that if the sun ever disappeared, the world itself would end. And in a way, they were right. Because one day, the sun really will stop being the star we know today. Not tomorrow. Not in our lifetime. Not even in the lifetime of humanity as we understand it today. But one day, the sun will change so dramatically that Earth will never be the same again. To understand that future, it helps to start with one simple fact. The sun is a star. That may sound obvious, but stars are not eternal objects. They are born, they change, and eventually they die. The sun feels stable because human lives are short. Civilizations are short. Even recorded history is tiny compared with the lifetime of a star. The sun is about 4.6 billion years old. That sounds unimaginably old, and it is. But in the life of a star like ours, that means it is roughly middle-aged. Right now, the sun is in the most stable phase of its life. Deep inside its core, hydrogen atoms are being fused into helium. The nuclear fusion releases energy. That energy pushes outward while gravity pulls inward. As long as those two forces stay balanced, the sun remains stable. That balance is the reason Earth has had a relatively steady source of heat and light for billions of years. But balance is not forever. Even now, the sun is slowly changing, and long before it actually dies, it will begin making Earth less and less friendly to life. This is the part many people do not realize. When people think about the death of the sun, they imagine a dramatic, final moment, a giant explosion, a sudden collapse, darkness falling across the solar system. But Earth's real problem begins much earlier. As the sun ages, it slowly gets brighter, not dimmer. Brighter. That means the danger to Earth does not begin with the sun vanishing. It begins with the sun becoming too powerful. Over vast stretches of time, that extra brightness will matter a lot. Temperatures on Earth will continue to rise. Oceans will gradually evaporate. Water vapor will build up in the atmosphere. Climate systems will break down. The surface of the planet will become harder and harder for life to tolerate. Long before the sun reaches the final stage of its life, Earth may already be finished as a habitable world. That means humanity does not need the sun to die in order to lose the Earth we know. In a sense, we may lose our living planet first. And that idea connects strangely to human history, because humans have always feared losing the sun, even when the sun itself was still there. During total solar eclipses, entire civilizations panicked. In some ancient cultures, people made noise, prayed, or performed rituals to bring the sun back. For a few terrifying minutes, daytime turned dark, stars appeared, and the world felt wrong. Much later, there were other kinds of darkness. After major volcanic eruptions, ash and aerosols in Earth's atmosphere blocked sunlight and cooled the planet. In 1816, after the eruption of Mount Tambora, parts of the world experienced what became known as the year without a summer. Crops failed, weather patterns shifted. People didn't literally lose the sun, but they felt what happens when sunlight no longer reaches Earth in the way life depends on. So humanity has already had brief glimpses of what it feels like to lose the sun. A darkened sky, a colder world, a broken rhythm of nature. But the real death of the sun will be something very different. It will not be a few minutes of darkness. It will not be one strange year. It will be the slow rewriting of the entire solar system. Eventually, the sun's core will run low on hydrogen. When that happens, the balance that has held the sun steady for billions of years begins to fail. The core contracts under gravity. Temperatures rise even further. New fusion processes begin in layers around the core, and the outer parts of the sun expand. This is the beginning of the red giant phase. The sun will become enormous. Its surface will actually cool somewhat, giving it a redder appearance, but its size will increase dramatically. It will swell outward into the inner solar system. Mercury will not survive. Venus will almost certainly not survive either. And Earth? Earth's fate is grim. There is still scientific debate about the exact final detail, whether Earth will be completely swallowed by the expanding sun, or whether it may drift outward just enough to avoid being engulfed for a time. But from the point of view that matters most, the answer is the same. Earth will no longer be a world where life can exist. The surface will be scorched. The oceans will be gone. The atmosphere will be transformed or stripped away. The crust may melt. The entire planet will become a ruin of what it once was. This is what makes the future of the sun both fascinating and unsettling. The star that created the conditions for life on Earth is also the reason those conditions will one day disappear. And it is not only Earth that will change, the whole solar system will be transformed. As the sun expands and later sheds its outer layers, it will lose mass. When the central star loses mass, its gravitational grip weakens. That means planetary orbits will shift. Mars, Jupiter, Saturn, Uranus and Neptune would continue orbiting, but the architecture of the system would change. The familiar layout of the solar system would no longer be the same. The inner planets would be devastated. The outer planets would continue in a colder, dimmer, stranger system. Everything would still be there in some form, but the solar system as a home would be over. And then comes the final transition. After the red giant phase, the sun will shed its outer layers into space. Those layers may create an expanding shell of glowing gas, a planetary nebula. Despite the name, a planetary nebula has nothing to do with planets in the modern sense. It is simply a beautiful cloud of gas ejected by a dying star. At the center, one thing will remain: the core. That core will become a white dwarf. A white dwarf is not a normal star. It is the leftover heart of one. It will be incredibly dense. It will be very hot at first. And it will no longer shine because of the same kind of fusion that powers the sun today. Instead, it will slowly cool over immense timescales. At that point, the sun will no longer be the bright life-giving star that defines our days and seasons. It will be the remnant of a dead star. Still real, still powerful in its own way, but no longer a sun in the sense that Earth has known. And this brings us back to the human question. What would it really mean to lose the sun? In the deepest sense, we would lose much more than light. We would lose the energy source behind forests, oceans, food chains, winds, clouds, rain and climate. We would lose sunrise, sunset, warmth on skin, and the stable rhythm that shaped every living thing on Earth. The death of the sun is not just an astronomy story. It is the story of how even the most familiar thing in our world has a lifespan. That can sound depressing at first, but there is another way to see it. The fact that stars die makes life more meaningful, not less. Earth is precious precisely because it is temporary. The warmth of sunlight, the blue sky, oceans, seasons, forests, and living worlds are not guaranteed forever. We exist during a remarkable window of cosmic time, a time when our star is stable, a time when our planet is alive, a time when the conditions are just right. And that may be one of the most extraordinary facts in the universe. One day, the sun will die. But today, it still powers every sunrise, every wave, every tree, and every breath. And for now, that is enough to make our place in the universe feel almost miraculous.